Welcome to part 2 of the periodic table groups and families. So far we've learned about how the periodic table is broken up into metals and nonmetals, and then we talked about how you have the alkali metals are group 1, the alkaline earth metals are group 2, and then we've also discussed about the halogens, which are our nonmetal, group 7. Well, our next group that we're going to talk about, we've already discussed in class, and you know this group very well. It's the group right next to the halogens, to the right of them, that last group on the periodic table. And do you remember what we called them? That's right. Good job. We called them the noble gases. So the noble gases are our last group. They have 8 valence electrons, and this makes them very unique. If you remember, we said they're noble. They don't want to react with anything. So this basically makes this group non-reactive elements. They prefer to be by themselves. They don't like to bond. Generally, they're all colorless. But remember when we did the gas spectroscopy lab? When we sent electricity through these gases that were in the tubes, they glowed a color. Neon was that beautiful bright orange, and then krypton, which we didn't have, but that glows a nice green. So these are your noble gases. The next group that I want to talk about on the periodic table is actually the largest group of metals on the periodic table. So that's your D block metals right here, which are called transition metals. And these are your metals that go from scandium to zinc and are your D block elements. These generally are the metals that we always think of as metals. They're all very, very good conductors of heat and electricity. So remember we talked about one of the properties of metals is that they conduct heat and electricity. If you think about this group, you've got nickel and copper and silver and gold, platinum. This is generally the group that people think of as metals. Nobody thinks of sodium as a metal or lithium as a metal. All these elements tend to be hard, dense, and have luster. Remember we've talked about this. Tungsten is actually used in light bulbs. It's the element in a light bulb that glows, which gives off the light. When you heat tungsten up, it glows a color. And then mercury is the only other liquid on the periodic table that at what we call room temperature, it's normal phase, it's a liquid. Do you remember the other liquid on the periodic table? It's a nonmetal. Bromine, that's the other liquid. And then, I don't know if you're aware, but in steel, a lot of times it's a mixture of metals. Sometimes we can actually add a nonmetal in there like carbon, but generally steel is made of iron, manganese, chromium, vanadium, cobalt, nickel. And then are there any photographers out there? Have you ever done your own developing? Well, if you have, you've actually worked with silver. One of the elements that's used in developing photography is silver. If you've ever gotten those little black spots on your hands after doing some developing, that's from the silver. And then we've already talked a little bit about copper, how it's used in wires and piping in our houses. So there's a huge variety of uses for these transition elements. Now headed back to the periodic table to look up another group or family. So the next group or family that we're going to talk about is within the transition metals. And if you remember, the F block occurs right here on our table. So right here would be where the F block would go. So if we could cut a line down here, then cerium, which is 58, would fit right here, and thorium, which is 90, would fit right here. So the next group we're going to talk about, because they fit within the transition metals, we tend to call them inner transition. So the inner transition elements are series, and we generally name them after the element that they come next to. And then the actinide series, thorium, comes right next to actinium, which is 89. So we've got the lanthanide series in the F block on top and the actinide series in the F block on the bottom. So just a little bit about these two groups. Generally, you may hear the lanthanides can be called rare earths. It's a name that's given to some of them, and they tend to be shiny reactive metals. The actinides are all pretty much radioactive and unstable. So there's not much to them, and we really don't deal a lot with the intertransition elements in this class. The next group that I want to talk about on the periodic table is what occurs between the metals and nonmetals. This staircase right here, the elements sitting on the staircase are very unique in that they have properties of both metals and nonmetals. And if you look, each element touching the staircase is what we call a metalloid. Boron, silicon, germanium, arsenic, antimony, tellurium, polonium. Now I know some of you out there are going, but hey, what about aluminum right here? And you're right, we didn't star aluminum. That's because aluminum has metallic characteristics. It is conducting, it has luster, it is shiny, luster, bendable, malleable, it forms positive ions. It has no non-metal characteristics. So we classify it, even though it sits on the line, as a metal. Every other element on the line has both metal and non-metal characteristics. So we classify them as metalloids. If you look on this line here, silicon, this is what's in computers. So we generally tend to try to use a lot of these metalloids to help build better, faster computer chips. We don't want our computers heating up so much, but we want them to conduct the electricity. Thus, it's really good to have metal and non-metal properties. The last thing on the periodic table that I want you to know is something you're going to need when we get to chemical reactions, but I want to introduce it to you now so you can start to memorize it. And that is our diatomic elements. For now, just write them down. I'll give you 2 ways to learn them, and then we just have to start memorizing for when we get to chemical reactions. So hydrogen is one, nitrogen over here is another, oxygen, fluorine, chlorine, bromine, iodine. Now, there are 7 diatomics, and if you look, you start at atomic number 7, you go over to oxygen, you go down to iodine, and you come over and you form a nice 7 in the top right of the periodic table, and then you just have to remember hydrogen over here as the 7th one. So again, 7 diatomics, you start at atomic number 7 and you go over to the halogens. But why don't we do the noble gases? That's right, they're noble. They don't like to react. So therefore, the only things that are going to be diatomic. So what does diatomic mean? What is diatomic? Well, these diatomic elements, they do not like to be by themselves. They end up in nature as pairs. So H2, N2, O2, F2, Cl2, Br2, and I2. That's why we call them diatomics. None of the other elements on the periodic table like to pair up with themselves. So there you have it, the periodic table of elements with all the different groups and families and various things you can learn off the table. If you want to have another way to memorize the diatomics, then go talk to Mr. McAfoose, Mr. Cronin, Mr. Moyer. They have this word that they use, which is Hofbrinkel, something like that. But remember, I can't spell, so this is not something I would teach you guys. So good luck with it, study it, and remember it.